Okay, we're looking at a hint for problem 937. We're given the system in difference equations. We work out and find the A matrix. We work out and find Z times A minus D inverse, and we want to find the inverse Z transform of this matrix. Looking at a few Z transform pairs. A to the K goes with Z over Z minus A. If we let A equals 1, then these diagonal elements are just going to be 1 to the K, because we have Z over Z minus 1. So these are just going to be 1 to the K, or just 1. Anyway, and these are 0 still. So the diagonal elements are 1 to the K. And then if we look at our two secondary diagonal elements, we have something like Z over Z minus 1 squared. So it's in this kind of a form. And so again, A is 1, and so we have a 1 on the top. The first term has a negative Z, and this one has a positive Z, so we're just going to have a negative Ka to the K here, and a positive Ka to the K here. Whoops. A is 1, 1 to the K. So now the tricky one is this term here. And so our, what is it? It's our 1,3 term is as something like a Z times Z minus 2 over Z minus 1 cubed. Our transform pair, we have this Z factor that we kind of take out when we're doing expansions. We have the Z, and then we have a and then we have a Z plus A. So we should have a Z plus 1. We should have something like, putting in 1, Z times Z plus 1 over Z minus 1 cubed. So we need something that looks kind of like this. Okay, so let's work on a partial fraction expansion that includes a term like this for the third order term. So we're going to write our Z minus 2, Z minus 1 cubed. We have a factor of Z out here. We're going to leave that off for now and multiply through back later. It'll be some A over Z minus 1 plus some B over Z minus 1 squared. And then for our third order term, we're going to have some C times Z plus 1 over Z minus 1 squared to make it look like the format that we want right here. So let's go ahead and multiply out. Excuse me. Let's go ahead and multiply out, or multiply through. Okay, let's go ahead and multiply through, alright, let's go ahead and multiply through by Z minus 1 cubed and see if we can solve for these ABC terms. So multiply through by Z minus 1 cubed, goes away on this side, we have a Z minus 2. The A term gets a Z minus 1 squared. The B term has just one Z minus 1. And the C term, they all go away, but then we have the Z plus 1. Alright, so let's work on this a little bit. When we have an equation like this with constants in it, we know that for this to be true for all of our Z, we can match up the coefficients. So let's look at the coefficients of Z squared on both sides, matching them up. On this side, there's no Z squared, so the coefficient is 0. On this side, the coefficient of Z squared, only A has one. The coefficient is A, so that says A equals 0. That will make things nicer. Let's match coefficients of Z. Left-hand side, coefficient of Z is just 1. Right-hand side, multiply this out a minute, we have Z squared plus, minus 2Z plus 1 times A. It's all going to be 0, but anyway, just for practice. So the coefficient of Z is negative 2A. Coefficient of Z here is plus B. Coefficient of Z here is plus C. Again, this is 0. And this says that we can say B is equal to 1 minus C. And then the last one, matching the coefficients of 1, constant coefficients, says that negative 2 left hand side is equal to right hand side, again a is going to go to 0, minus b plus c. So what does this say? This says, well, let's go down here. Negative 2 equals negative b, well, we said b is 1 minus c, plus c. So that's negative 1 plus 2c. So that says that c is negative 1/2. Let's add 1 to both sides and divide through by 2. Okay, so then our b is 1 minus c, 1 minus negative 1/2, looks like 3/2. Alright, so we can go back to our equation then. Z minus 2 over z minus 1 cubed. The a term went to 0, b we just said was 3/2, and c is negative 1/2. So we can go back and get our transform. Let's just go up here. So let's rewrite. So let's go ahead and multiply through by our z now. So we really had z times z minus 2 over z minus 1 cubed. And that's going to be 3/2 z over z minus 1 squared plus negative 1/2 z plus 1 over z minus 1 cubed. Going back to our little table here, a over z minus 1 squared, we have the form here. So to take z inverse of this first term, we're going to get 3/2, and then it's the squared form, so it's going to be k a to the k. 1, and a is 1 to the k. Our other term here, take its z inverse, inverse z transform. We're going to have, we have it in a form kind of like this. Remember, a is 1, so we have a z plus 1 over z minus 1 cubed with a z here. So we're going to have a negative 1/2 factor, and then we're going to have k squared a to the k, 1 to the k. And so our A matrix become, our 1, 3 terms becomes 3/2 k minus 1/2 k squared. To find the solution, we just go back and say, well, x of k is a to the k times x of 0. X of 0 was given in the problem, and we just found our a to the k.